Well, hi everyone, and welcome to this ISOP Study Group webinar. My name's Mike K. Smith, and I work for Pfizer in Sandwich. And today I'd like to take this opportunity to talk to you a bit about something I've been working on, an R package called rspeaksnonmem. So the problem that I'm trying to address through this package is to produce reproducible workflow for modeling and simulation tasks, starting from and completely contained within R. So I'm looking at estimation with NONMEM, model qualification and diagnostics, updating models with final estimates from that estimation, and writing NONMEM control streams back to file, and then performing a visual predictive check. Now, the key thing about this is that all of this is with the aim to produce a reproducible report of run steps with something like knitr. R Markdown and knitr and R notebooks are a great way of sharing code that's reproducible. And I think it'd be really worth tapping into this for use with NONMEM and similar tools. Also, within the R world, there's the potential for Shiny applications to wrap all this together. Clearly, there's lots of work going on in that area, and I think if there's an R package that allows us to work with NONMEM, work with PsN, and wrap all that into Shiny, then that would be a great step forward in user friendliness for running these kinds of steps. Now, the thing to point out here, and I want to be very clear about this, rspeaksnonmem isn't going to replace rspeaksnonmem or PsN. And it's not just rehashing rspeaksnonmem in R. Rather, it works with PsN and works in executing nonmem from within R. And so really the idea is that this is an interface into running PsN from the command line, but calling all those functions from R. And we could extend the workflow of PsN, we could wrap around PsN functions with rspeaksnonmem, but it doesn't replace that functionality. One place that we've taken a look at using this kind of methodology is in the DD Moore IMI project, where Andy Hooker showed running PsN and NONMEM from R alongside PopEd to do adaptive optimal design. So in that sense, you can imagine extending functionality that's already there and creating new workflows and new methods, wrapping all this together within R. So there's various things that rspeaksnonmem does. The first of these is very simple, and it runs nonmem. So if you have existing control streams, then it can run nonmem and estimate parameters, or it can execute PsN routines from within R. And essentially what we're doing is that we're dropping down to the command shell, command line, and executing nonmem and PsN. And I've written some wrappers around PsN that would do things like checking the PsN options before it runs, that kind of stuff. We can also use R to modify NMTran control streams and write these back to file. So there's a Mango Solutions R package called rnm import, which takes nonmem control streams, it imports those, it parses out the control stream into R objects, which we can then manipulate, work with, and it's easier in some ways to work with the parsed values than just working with plain vectors of character strings. So I have a version of rnm import that enhances some of the Mango's R package functionality, especially in this import nmmod functionality. But we'll take a look at that in the demo to show how that works. And then the other thing is the writing out part of rspeaksnonmem. So given that parsed set of outputs, rspeaksnonmem writes that back to a NONMEM control stream, an NMTran control stream, using a template model to dictate the order of the blocks in the model, so that your new written out control stream looks as familiar and looks as much like the original NMTran control stream as possible. And then, as I've said, we can build workflows incorporating this, and we can capture output from PSN and outputs from NONMEM in knitr reports or in notebooks, which is a slightly newer functionality from RStudio. And we'll see how that works in the demo. Now, the benefit of all of this is reproducibility. So if I start with a NONMEM template model, then I can pull it into R, I can make any changes to that control stream within R, and you can track very easily from that control stream in R what I'm doing. That R script, you can see what I've done to the control stream, what I've updated, whether I'm fixing or unfixing parameters. One of the things that what I've done with rspeaksnonmem, is to split apart that parsed NMTran control stream into elements pertaining to data. So that's the $data and $input statements. So it's easier to change data sets. I can change the $estimate or $table statements, if you like, the task properties of that control stream, and also the parameters settings, or the initial values for thetas and omegas and sigmas. And so this way, we manipulate certain aspects of the model. The kind of core structural elements remain unchanged. So as I've said, the reading part of RNM import reads and parses the NMTran control files. That function retains the raw control stream text. So these are the character vectors of each line of the NMTran control stream, but it also parses that into R objects. We work with those, we manipulate those parsed objects, and then we write those parsed objects back out to file using that template, and we treat the kind of core model objects as unmodifiable. So those get written back to file unchanged. And that means that kind of limits what we can do, and if you like, the damage that we can do with rspeaksnonmem to that template model. So one of the things that we need to think about at this stage is that the template model is probably best set up to have parameter estimates for each parameter within the model. Even if these are fixed to 0, you have in everything that you might want to work with within that template model. You might want to have between subject variability on each parameter, but then have the omegas fixing certain elements to 0. And then evaluating different models is simply a case of either fixing or estimating parameters within your model. And so again, it keeps that core bit of the model unchanged across tasks. So as I've said, one of the things that we're doing is that we can update objects within my parsed collection of our objects. So I read in from my template model the theta block. I have that parsed out, so I know what the lower bounds, the initial values are, what the upper bounds are, whether they're fixed. And then I can update only that element in an update statement, and then and that creates a new parsed collection of objects ready to write back out to file. And the update function only, you only pass in the bits that are going to get changed. So again, it's easy to see what has changed from step to step. Now, there are other packages that do very similar things to rspeaksnonmem in running NONMEM, running PsN. And packages like metromrg work on manipulating the vectors of character strings. I see that there are pros and cons in doing that. It involves quite a lot of textual searching and looking for patterns within the text strings. And I think that it's somewhat easier to see what's going on if you're, and hopefully more robust if you're dealing with these parsed objects. Of course, it means that you've got to have good syntax, good understanding in that parser to know what you're looking at from the non-mem perspective, but also in writing out, you've also got to have some, good handling of all those parsed objects and know what they go back to uh, from the non-mem side, so that you work out, uh, you eventually get valid non-mem code at the end of the day. Now, rspeaksnonmem then is essentially a collection of tools, which you can use some of, or you can pick and choose which bits you want to dip into. There's a collection of tools for extracting elements of that non-mem control stream. So a function called getNMBlocks, which basically just extracts all of the different blocks from the parsed control stream. But you can also get just the data objects, or just the parameters objects, or just the task properties objects. And in some senses, if you're familiar with the ddmore R package that we created for MDL, this is very similar. So we're dipping into non-mem now and extracting data objects, parameter objects, task properties objects, in the same way that we did for the MDL code and extracting those blocks and objects from MDL. As I've said, there's a tool for a function for updating the parsed objects called update model. And one of the bigger bits of code is for writing out that parsed object to file, so that write nm control stream takes the collection of parsed objects and writes back out to file. And then there's a collection of functions for running NONMEM and PsN from R, which we'll look at when we get to the demo. So one is defining the executable, and by that I mean how do you find what executable file or function you're going to call at the command line. So how do you know where to find nmfe72.bat, or how do you call the PSN routine? So we'll have a look at that in more detail. But I've wrapped that up into some functions called estimate nm, where you basically say, this is the model file I want you to run. Here's how what I want you to call at the command line, or what tool to look for, and what version of that tool. And then it will run NONMEM for you. Similarly, there's execute for PSN, sumo, bootstrap, VPC, and run record and tools like that. There's one called call PSN, which is more of a generic wrapper. And what that does is to say, for any PSN tool, then collect together the file that you need to pass to PSN, what the PSN routine is called, what version of it you're looking for, and where it's installed, and then call PSN will pass the relevant files through. So if your favorite PSN function isn't covered here at the minute, today you can just tap into this call PSN function. But ultimately we could extend this set here, this extended wrapper functions, to cover most of the PSN functionality. And of course, what you can then do is to write your own workflow. So you can dictate what steps do you want to take on each non-mem model, or what steps do you want to take to combine different steps to do more complex workflows. But ultimately, you can create your own R Markdown documents using knitr. You can summarize each run in an HTML output report, so that if you just want to run a workflow that will estimate parameters, provide a nice table of parameter estimates, run some diagnostic plots, and perhaps a VPC, you can put that all in an R script or in a function, feed it the model that you want it to do that on, and have it run through those common steps, and produce a nicely formatted HTML for you to be able to, at a glance, see what your model has done. And as I said at the beginning, ultimately what we could think of is to create Shiny applications that wrap around all of these functions that would allow you to run and then review non-mem output in a similar way that Mark Laviala has done for Monolix using MLXR and similar tools. Okay, so now I think I'm going to switch to a demo and kind of show you how all this works. And so if I just swap to RStudio, here what I have is with the package I've created some RMD files, some R Markdown files, which explain the overview of how to work with rspeaksnonmem. And these are all in the vignettes directory with the package. And so I've also provided some data sets and the warfarin control file within the example data. So one of the things that I'll do is first is to copy those files into the vignettes directory. And here's the command for running estimate with nonmem. Now the first thing to notice here is in this call of the function, I'm explicitly telling rspeaksnonmem what the executable command is for the command line. So when I open up the DOS prompt or the Linux shell, what is the name of the function that I would write here to call nonmem? And what that allows me to do is to be very precise about where I'm running it and what version exactly, explicitly, where I'm going to find nonmem. And then the model file I'm passing in. And one of the things that this function does is to make some assumption about, okay, if you pass in the model file, then we'll make an assumption about what you want the LST file to be called or the output file to be called. But you can see here one of the things that you can do is you can explicitly say what is the LST file that I want or what's the file extension I like for my output file. And then clean here is analogous to the PsN cleanup routine. And what that does basically is just to clean up the intermediary files that nonmem produces when it's doing an estimation. So it'll take a little moment to run this. If you want to keep all of the intermediary files for nonmem, then if you set this to 0, then it will keep all of those files. And in the background here, you can see that it's running nonmem. And producing some output in my directory. Okay. So from here, I can come and have a look at its run0.lst. And I can do the usual thing of just checking that that's run as expected. Okay. So then the next thing I might want to do, having run nonmem, is to call sumo from PsN. And I'm calling sumo and PsN in a slightly different way here. Instead of saying what the command is, I'm telling rspeaksnonmem where I've installed PsN and what version of PsN I'm running. And the reason for doing that is that it will look under this installation path and it'll know how to find the Perl executable. And then it will attach sumo and this version number to the Perl script and then use that as the command for running sumo. So you can see here, I'll just recreate that step that you were just looking at. So what you see at the top here is the actual command submitted at the command file, and you can see that it's calling Perl executable directly, and then passing in the 460 version of sumo as a Perl script with run0lst as the input. And so within your notebook, you can capture the sumo output for that run. So then the next thing that you might want to do is to create some run diagnostics. And first thing that we have to do is to is to create the expose database object. And then what we can do is to run the diagnostic plots. And because this is a notebook, one of the things that you get is that the plots here are incorporated into that notebook. And so you can get all your familiar expose diagnostics. This isn't really special to R Markdown, but it's showing that the incorporation of the expose output in this R notebook format, which is quite nice because with the R notebook, if I was to share this HTML with someone, they would be able to knit between these two individual plots to see what's going on there. Okay, so the next step that you might want to do for this first run is to do a VPC. And here I'm passing in run0ctl. I'm the install path for that. Again, for VPC, I'm telling it where I've installed PSN, what version I'm running, that I want to put the output into a working directory here called run1vpc, that I want to sample 100 new data sets. You pass it a seed. And then the thing here, the PSN options here, these are all PSN options that are valid for VPC. Okay, so here I'm saying that I want to pick up the final parameter estimates from run0.lst. I want to have 5 bins, automatically chosen the spacing of those, and I've got minimum points per bin of 2. Now we'll see what that does in just a second. But what's happening in behind the scenes is that within this VPC function, I've specified the mandatory required settings for VPC of samples and seed. So VPC won't run if samples and seed are missing, or at least it would use a default. But then for PSN options, I can specify name value pairs there to specify all of the options that I want to run with VPC. And what rspeaksnonmem does is to compare these name value pairs with the help file output for each routine, or the generic PSN option help file, to check whether those option names are valid, and also to check that the type of number or the type of value that I'm passing in is valid for that option. And so you might struggle to see it here, but the min points per bin is actually not the correct option for VPC. It should be the minimum points in bin. But what this does is that it says, okay, you've specified an option here which is not a valid PSN argument, but I'll run whatever needs to be run with the valid arguments that you've passed. So instead of throwing an error, it just throws a warning to say, hey, this isn't a valid option. And it doesn't try to guess, but it continues on anyway. And one of the things that we might want to discuss is whether that's a sensible thing to be doing. But anyway, this is now run the VPC, so now I can plot the output in my notebook here. I'm sorry, that plot seems rather small. There you go, that's slightly better looking. Okay, so that's really all that I wanted to show. That's the very basics of working with rspeaksnonmem to estimate the model parameters, then perform some diagnostics, run a VPC with PSN, and plot the output back to my notebook here. But you can see that for a given run, what we could do is that we could provide this kind of notebook format, and using the power of knitr and R Markdown and conditional handling of outputs, you could then create a nice HTML or notebook output for each run that would summarize what the parameters are, my diagnostics, my VPCs, and provide all that for the analyst to interpret once they're for each run. Okay, so another facet of rspeaksnonmem is to modify control streams. So what we saw there was just running an existing model without changing it whatsoever. Now let's have a look at, oh, excuse me, I need to just copy some files over. There we go. So what we're going to do now is we're going to have a look at this import nmmod function to see what happens when we import the nonmem control stream. And the first thing that nmmod gives us is something called raw. And as I said, that's just the vector of each line of the command line of the nmtran control stream. So this is just exactly what we would see in this file. R has read that file and returned that parsed output. Yeah, sorry, it's just got slightly folded there. Okay, but the other thing that it gives us is parsed contents. Now, import nmmod takes each problem from the nmtran control stream and creates a list of problem contents for each problem. And so what you'll see here, what you'll see here is the parsed list for that first problem. In this example, there's only one problem, so it's somewhat easier. But you can see here, here's the omega values, and you can see that there's a block matrix. It's of size 2. It's not fixed, and it's not same, and each row has a name. Okay. And then there are for sigma, similarly, we've got the problem statement here as an object. I'll come to some of these other ones in just a second, but you've got subroutine, input, information about the data set, and then things like the PK and the error slots within that object or items within that list are just vectors of character strings. So this is why I'm saying that when it comes to writing those back out, I'm writing those back unmodified because I want to work with initial estimates, bounds, perhaps change a data set, perhaps changed some of the input statement, perhaps change the table statements or the estimation method, but retaining that same consistent model file. Here we're looking at the theta values or the initial values for thetas, which are converted into a data frame. So you can see each of those has a name, it has a lower bound, an initial value, an upper bound, and logical about whether it's fixed or not. And the idea here is that because this is a data frame, it's somewhat easier to then go in and just substitute this initial value column, update the values there, leaving everything else unchanged, or change a row, and we'll have a look at that later. So certain elements are data frames and certain elements are list values, but within this problem contents, you've got all of that information parsed out. So here's the thetas for, sorry, I think that's the omega values, initial values for Ka and T lag, and for sigma. And here's the table list. So again, it's a data frame, but we've got file names, columns in each data frame, in each table, and some options here. Okay. If I say get nm data objects, then essentially what it's going to do is to go into that parsed collection and just pick out the data relevant section, so the dollar input and dollar data. Similarly, for get nm parameter objects, it will return just the parameter things, and for task properties, it just returns the dollar estimate statement, COV statement, and tables as a data frame. Okay. Now, one of the things I can do is I can update my theta. So if I wanted to update the original theta where I had t-lag fixed to 0, within that data frame, I can update the pop t-lag row, and I can give it a lower bound, an initial estimate, an upper bound, and then say fix as false, which then says to NONMEM to estimate those parameters. And then I can update my model starting from this template and pass in those new thetas. And what you'll see is that for the theta values here, pop t-lag is now to be estimated, and it's got an initial value, an upper bound, and fix is false. So just by saying update the model with one element, it leaves everything else unchanged and just changes the thing that's been updated. Okay. So then it's also possible to change just lower bounds or initial values. So here, what I'm doing for new theta 2, I'm creating new initial values, and I can substitute into that theta data frame that we're just looking at here. I can just substitute that estimate column with new values. And if I do that, you can see that the estimate values there have changed. Finally, what I'd want to do, having got those updates, is to write all of that collection of parsed objects back to file, and I'm going to call that file warfarin2, just so you can see any differences. And so here you can see for pop t-lag, I've got an initial estimate, an upper bound, and instead of being fixed to 0, we're now estimating it. But comparing back to the original raw file, what you'll see is that the order of statements here is retained. So if I was to do a diff between this file and the original, then it would be very easy to see what's changed. One of the things that I've had to do just now, and I'll look to see how to handle this better later on, is to handle comments. Because clearly, comments could be anywhere throughout this model file. One of the things that's perhaps difficult is to know what those comments, what place those comments are related to. And of course, if I update something, I don't want to then invalidate the comments. So that's just one piece of work that needs a little bit of thought. So for today, what I'm doing with write control stream is just to ignore line comments. You'll see here that if I've named my parameters, then I put those names after comments so that they're retained when I read them back in or when I use them in other places. Okay, so that's modifying the NONMEM control stream using rspeaksnonmem and then writing back out to file. So one other thing, and I'll maybe not run this, a lot of this, but just talk you through it, is where you want to, a lot of these steps are very similar to what we've done already. But one of the things I want to draw your attention to here, as we talked about modifying elements of the NONMEM control stream, and when I talked about the template model having parameters like thetas for all of the parameters you might want to estimate, even if some of those are fixed to 0, that allows us to have this kind of workflow where we can then say, well, there are two different models I want to have a look at. One where I fix t-lag and one where I estimate t-lag. And so what I can do is specify both of those, and then I would have a theta data frame or theta set where I'm fixing t-lag and a different one where I'm estimating t-lag. And you can imagine having combinations of these for different models. If you're treating the residual error as combined as using thetas, thetaizing your residual error, then you may want to incorporate those into your theta block. But similarly for omegas, I can have a version of the omega where I have a block between clearance and volume, but no T-lag, or one where there's a diagonal between subject variability, but still no T-lag. And you can specify those like this. And then defining my runs and the different models that I want to evaluate is simply a case of combining different theta options, omega options, and so on. And nominating a run number here substitutes that run number into the SD tab, cotab, patab table file output names. And so you can see how you could build up a collection of different runs that you wanted to evaluate simply by nominating which thetas you want to estimate, or what your omega structure is, or what your residual error structure is, and so on. Then what I've done here is to I've set up a workflow that is going to be consistent across all of those models. So in this workflow, what I'm doing is to, write the collection. So the run 1 and to run 3 up above, if you remember, those are the parsed objects. So the first thing I need to do is to write those guys back out to file. And then I'm going to use the execute statement within PsN to run NONMEM, sumo to pick up the output and summarize it for me, and then run a bunch of expose diagnostics. And so what you can see here in this output, as I've said, I'm not going to bore you by running through all of this. But for those run 1 to 3, for each run, it performs the PsN execute. It runs sumo. It provides the feedback of and the summary of my run and whether the estimation has gone okay. And so you can see run 1, run 2, there's some warnings found in run 2, and run 3, and you can see there's some warnings there as well. So it says to me that there are some things I need to do to go and tidy up my model and make it more robust, or to resolve some of those issues. And so maybe what I need to do is to have a look at the results of my diagnostic plots here in the light of whether my model has completed successfully or not. And in fact, what we could do with rspeaksnonmem and a conditional markdown output is to then condition on whether you actually show the exposed diagnostics if there have been any problems with that NONMEM run. But for now, just as a demo purposes, I'm producing these diagnostic plots for each run. Okay. Now, when you're creating a workflow to go across a number of runs, you've got to then think about how to handle those cases where something untoward happens. You'll see I'm using execute from PsN here rather than estimate with NONMEM, and that's because execute within PsN has some nice additional functionality and options to retry or to tweak the initial values if there's any problems with the convergence or the maximum likelihood estimation with NONMEM. So that's a useful way of handling what might otherwise be an error. So finally, if we look at just running stuff with rspeaksnonmem, as I showed you initially, with estimate nm we can specify the command exactly, and with sumo I said we need to let it know what the install path is and what the version is. You can use install path and version with estimate nm alternatively, and with PsN you can specify the command explicitly. So that's kind of either or option here. But the difference is that if you use install path and version, then it makes some assumptions about where to find those files and how you want to call it. Whereas if you want to be very precise for your own setup, you might want to use this command here and explicitly define how you're going to call NONMEM or PsN. But this define executable function, there's an option to it called search command, and what that does is to say if I'm calling R at my desktop at my command prompt, tell me what that equates to. So if I just open up a command prompt and type R, it's the perils of demoing. But if I search command here looks on the path or uses syswitch within R to work out what this single R command at the command prompt equates to. So that basically returns, for this command, what's the full path to the executable that you're calling. And on Windows, it looks on the system path, and other operating systems, it'll look up any shortcut definitions or executables. So the alternative is to say, okay, here's my tool, which is going to be called NONMEM. And so it knows, it searches for that string NONMEM under a given install path if you're using this search command. And you can see here that what it's doing is within C/nm72, it's looking for everything that's .exe or .bat that's under that installation path. Now, generally speaking, you probably won't call this directly, but it's kind of a useful tool to have under the hood if you need to then query where can I find executable values or executable scripts or things that I can run at the command line. Similarly for VPC, when you've installed PsN, there's actually a number of different ways that you can call VPC. So you could call vpc-460.bat, or there's the Perl script. And as I said that earlier, and there's also vpc.bat if you're making an assumption that you don't have to explicitly name the version. Now, as I've said, for my functions that call PsN, what I'm preferring to do is to say, under the PsN installation, I'm going to know what version of Perl is there, and I'm going to know what I'm going to call the Perl script directly, so that I can equate very closely what Perl version, what PsN script I'm calling. The .bat files wrap that up into higher level functions. And so as I've said, if I do define executable for the VPC, my install path is here, my version is this, then I get this string here, which is calling Perl first and pointing it to the appropriate Perl script. I have a function called validate PsN options. As I said earlier, what this does is to take a name value pair list from usually from the PsN function call, and it checks that those are valid. Those name value pairs are valid for the function that you're trying to call. So here I've got picky is yes. Well, picky should be true or false, not yes. Autobin is 4. Well, autobin is a valid PsN option, but not for execute. And then my directory is the current working directory. So if you run validate PsN options, what it will return is that it will say that autobin is not a valid argument for execute. Yes is not a valid value for the option picky. But then the last thing that it actually returns is whatever the valid PsN options are and what their values are. So as I said before, it doesn't completely stop. It pairs together the name value pairs that are valid, and it just ignores anything that's not valid, but gives you a warning. So then There's also this call PSN function. Now, as I've said, there are wrapper functions for the kinds of PSN tools that I would use most frequently. But call PSN is kind of the catch-all. And it says, well, if there's a tool that I haven't wrapped up here, like linearize, then I can call PSN with linearize. I can pass it the install path versions, the file that I want to use with that, and PSN option lists, and it will do validate PSN options. It will call that linearize function and call the PSN routine that you're interested in. There is one small catch, and that's to do with call PSN for functions like run record, because run record doesn't actually take a file, and so that then I needed to kind of rejig that slightly. There may be other PSN functions that exist that don't require an input file, and over time I'll resolve what to do with those, and or maybe change call PSN to not insist on having a file here. Okay, so that's all I was going to show for the demo. The last thing to say is where you can find rspeaksnonmem, and it's on GitHub. And you can go to my repository here, and I think this is it. And you can see here, you should have, well, by the end of today, we'll have updates for all of the RMD files that I've been showing, and the slide deck from that you're looking at here. What you'll need for today to run rspeaksnonmem is my version of RNM import. So I said that this is a package that Mango Solutions have developed. I had to make some changes to import nmmod to make it work with rspeaksnonmem and to capture aspects like the block structures for omegas and sigmas and so on, and whether they're the same or fixed. So I made some changes to that function. I've made a pull request back to Mango Solutions to update their version of RNM import, and hopefully that will be progressed. But in the meantime, if you want to try this out, then you'll need my version of it, which is here. So with rspeaksnonmem, it's still work in progress. I'll be merging in what I've been showing you today. It's in a branch at the minute, but I'll be merging that back into the main branch of code as soon as possible. I have done some testing on rspeaksnonmem. So one of the things I've been doing is to, if I just look at the tests directory, because the writing out of the nonmem control stream is somewhat tricky, and just making sure that what you've written out corresponds to what was originally in that file. What I've done is to run through a raft of different examples, some from the original NONMEM installation, some from MetromRG, some from RNM import, some kind of stock examples like moxonidine and warfarin and theophylline. And just I've read in and parsed the objects using RNM import, written that parsed object out to file, and then read it back in using RNM import and compared the two parsed versions. And so what you're seeing here is the results of comparing the original and the written version. And in most cases, things go quite well. There are some very minor things here that mean that they're not absolutely identical. So what I've done in the $data statement is I've put quotes around the dataset name. So in that way, it doesn't quite work, or it doesn't quite give you exactly the same. But actually, I feel that this is perhaps more robust in the long term. So I'm although that's not exactly the same, I'm not too bothered. Similarly, for some comparisons where there was a block in the omega in one version of the code, that's not been named, and in my version perhaps it is, and so you don't get a one-to-one match of between the original and my written out. So I've done those kinds of tests. I need to complete a set of testing to make sure that so that every time I make changes, I can make sure that I'm not breaking anything. And I need to build the package to get it ready for a kind of CRAN standard. But in the meantime, I'm really happy for anyone to contribute, and you can do that via GitHub by forking my repository, making some changes, and making a pull request. Also, if you want to try this out, and if you have any bugs or if you find anything that you would like to improve, please, please suggest changes via the issues page within GitHub. So there you can add, you can submit a new issue, and you can see here that Devin has already made some, and Bill have made some comments. One of the things that Devin was suggesting is to slightly change, instead of using the generic rsys function, there are some alternatives that do some clever handling and scheduling of system jobs. And so in that respect, that handling of we can have better handling of system jobs so that you could set the job running and return to R instead of waiting for it to finish. But thank you for attending today's and watching this webinar. I hope you find it interesting, and I look forward to hearing your thoughts and inputs via the GitHub issues. Thanks very much.